Thank you very much, Ralph. Next up, we have Rethinking Ephemeral Environments in Kubernetes. And I'd like to see Michael Levon over here to get a mic up. So Michael, are you here? Am I saying your name wrong? Are you not here? All right, I'll figure that out. You may take it away.
Okay, thank you. Hi guys, this is Prakash, and this is probably going to be a little lower in the tempo because I'm not used to the tempo that Lori followed. So rethinking ephemeral environments in Kubernetes. So ephemeral environments have been in existence since the age of Stone Age. I think, if I may call, from the ages of Jenkins era. So, but how we implement that in today's cloud native ecosystem is what I will be discussing here today. So ephemeral environments, quickly, if I can tell you, they are short-lived environments or deployments that we generally do for cost effectiveness, and they are dynamically created for, let's say, each developer, each feature that you are building, and then dynamically destroyed as and when you merge your code to your release candidate or your staging branches, right? And why exactly do we need ephemeral environments? Because in your organization, you may have different functionalities being built upon in parallel, and you may want to want to isolate all those functionalities from each other when you're testing a particular functionality. For those kind of scenarios, what we do is we use ephemeral environments to create a particular feature branch for a feature, and we deploy it across that particular environment, and then we test out that functionality and then finally merge it against other features to do integration testing. So developers can focus on their functionalities while the test integrations and all can be done in the staging branch or the release candidate branch itself. So that's why we need the ephemeral environments. The conventional approach of ephemeral environments, if we are deploying on non-containerized environment, would be just to maybe build your images, build your binaries, and then spin up an infrastructure using a Terraform script or something, and then setting up the configurations, then going ahead and deploying, and then once you do your testing and once you do not need that particular environment, you can go ahead and destroy it, nuke it. Right? But in the Kubernetes approach, what we do is you build the container images. You do not have to spin up an infrastructure, because on Kubernetes side, you can just create a namespace, or you can utilize an existing namespace which is already there and deploy your configurations over there, deploy your workloads, and then once you're done with your testing and everything, you can go ahead and just either delete the namespace itself, or you can scale down all the workloads using any of the tools that are there in the Kubernetes ecosystem, right? So this is how the Kubernetes approach works. It's not necessary to create and delete every time. That's how we did in the conventional approach, but it's not necessary to do that in the Kubernetes approach, because in Kubernetes, you do not have to have a infra cost associated with a namespace. So a namespace is a free thing you can have. You just have to scale down your workloads which are there in your namespace, and you're good to go. So you let the cluster autoscaler do all those descaling activities, and you can have your Kubernetes environments reused when you're using the ephemeral environments. That was about it. So we have implemented a lot of scenarios where we have created these scenarios where ephemeral environments can be reused by the developers. They can be engaged with a lot of other functionalities as well. We are at booth R13 at KubeCon if you want to visit and discuss any of those scenarios of yours. Thank you.